Okay, good morning to all of you. In our last class, we have been discussed these two problems and this one also. That means these are the non-homogeneous linear differential equations, and we solved these numericals by using method of variation of parameters. Okay. Before that, we have been discussed in detail about method of variation of parameters. You can check those videos. In today's class, we are going to discuss about operator method to find particular integral, that is your yp. Okay. How to find out the particular integral by using method of variation of parameters, that we have already discussed, and by using method operator method, how to find out the particular integral, that we are going to discuss in this class, and also some numericals regarding this. Okay, so as we know that in general a non-homogeneous linear differential equation is written as in this format, that is your a1 dny by dxn plus a2 dn minus 1 y by dxn minus 1 and so on, a and y equal to function of x. Here a1 a2 and an are the constants that we know. Let this is your equation number 1, right? And also we know that if we are going to consider d by dx equal to d, then the above equation number 1 can be written in this format, that is your a1 dny plus a2 dn minus 1 y and so on, a and y equal to x, which is the function of x. Okay, capital X. That means this is a function which is the function of x, that may be trigonometric, that may be logarithmic, that may be exponential, anything. Okay, so here this left hand side can be written in this format, a1 dn plus a2 dn minus 1 up to an y equal to x. Let this term up to this much, you can see this term contains the d terms. So let function of d equal to this much. So this expression or this equation can be written as function of d y equal to x. Let this is your equation number 2. From equation number 2, it can be found that fd is operates on y and we get x. So from this expression, one can be perceived that this is one type of operator which operates on y and we found x, right? So that implies y will be 1 by f of d into x. This is the solution which satisfies the equation number 1. So here, if we are going to consider y, which will be equal to 1 by f of d into x, then this y has to be satisfied this equation number 1, and this y equal to 1 by f of dx is called as your particular integral. Okay, because as we know that yc complementary function only valid for this one, d square y, sorry, d ny dn minus 1 y so on plus y equal to 0. If right hand side will be 0, then we can find out complementary function. But here from equation number 1 we derived this one y equal to f 1 by f of d into x. So therefore, as this is the solution of this expression, this non-homogeneous linear differential equation, so hence this will be called as your particular integral. Okay, so this will be nothing but your y p. You write like this, y equal to 1 by f of d into x equal to yp, that is your particular integral. Okay, so on the base of type of function, here x is the function of x capital X is the function of x, but this x can be anything. That can be exponential, can be trigonometric, can be arithmetic, etc. It can be logarithmic, like this. So on the base of types of function x, that is your exponential or trigonometric or arithmetic, etc., there are some rules or procedures we have to follow to evaluate particular integral. Okay, so first we have to consider if this x will be exponential function. Rule 1, if capital X will be in the form of this one, e to the power x, then what will be the particular integral? In general, we know that the particular integral is nothing but 1 by f of d into x. This is the general. Okay, so let x equal to e to the power x. So here dx, as we know that d equal to d by dx. So d, when this d is operated on x, where x equal to e to the power x, so d e to the power x will be a e to the power x. d square e to the power x will be a square e to the power x, and so on. d n e to the power x will be a to the power n into e to the power n. Okay, so therefore f of d into e to the power x, if I am going to consider, that is nothing but a1 dn plus a2, because f of d we consider this one, right? Let this is your f of d, that I am going to substitute over here. That a1 dn d to the power n plus a2 d to the power n minus 1, and so on, an into e to the power ax. So here we found dn e to the power ax will be an e to the power ax. Okay, ax. So hence this term, when operate upon this, we can found an e to the power ax. So here for this term it will be a1 a to the power n, for this one a2 into a to the power n minus 1, and so on, an e to the power ax. Okay. So here we can see that this summation, whatever the terms are there, all are belongs to a only. Okay, so in short I can write this sum or this summation as your f of a, because this all the terms whatever we have in this summation, in this bracket, all are belongs to a only a. Here a1 constant, here a to the power n itself the constant. So this is the function of a, and e to the power ax is there, e to the power ax. Okay, now operate 1 by fd on above equation both the sides. So 1 by fd I operated left hand side and right hand side. What we are going to get here, 1 by f of d into e to the power x. Right hand side will be 1 by f of d into fa into e to the power x. So here f of d got cancelled, e to the power x equal to 1 by f of d, here f of a e to the power x. So here f of a, if I am going to take to the left hand side, then it will be 1 by f of a e to the power x will be equal to 1 by f of d e to the power x, or we can write 1 by f of d e to the power x equal to 1 by f of a e to the power x. So here whenever we have this x is a exponential function, then yp is nothing but 1 by f of a into e to the power x, which is your so-called particular integral for x equal to a exponential function. So here a may be anything. So here a can be a imaginary number, can be a real number, 2, 3 or I, anything. Okay, so here 1 by f of a into e to the a. And here one thing we have to remember, this f of n not to be 0. If it will be 0, then yp not to be determined, because 1 by 0 will be infinite. So this will be valid for f of a not equal to 0. Otherwise this rule not to be valid. So what we have to do, if f of a will be 0, then what we have to do, or what we are going to get, that we are going to discuss. So before that, by applying this rule, that if a function x or the source function or right hand side function of the non-homogeneous linear differential equation is a exponential function, then the answer will be 1 by f of a into e to the power x. So using this one, we have to do a numerical. So here it has been given that d square y by dx square minus y. This is first example, you can say d square y by dx square minus y e to the power 2x by operator method. Evaluate this one uh, by operator method. Not evaluate only, evaluate the solution. Solution of this much. Solution of this much by operator method. So here given that d square y by dx square minus y e to the power 2x. So as right hand side is a function of x, so this is a non-homogeneous linear differential equation. So this can be written as d square minus 1 y equal to e to the power x. As we know that the solution of this one will be y equal to complementary function plus particular integral. So if we are going to consider the auxiliary equation, then it will be m square minus 1 equal to 0, m equal to 1, m square equal to 1, m equal to plus or minus 1, two distinct roots. So hence complementary function will be c e to the x plus d e to the minus x. Now we are going to find out the yp, particular integral. Given that d square minus 1 y equal to e to the 2x. Okay, so this is nothing but your so-called f of d. This is nothing but so-called your f of d, or you can say operator which is operated on y. We found e to the power 2x. So instead of d square minus 1, we can write f of dy equal to e to the x. So y, here y or the so-called particular integral will be equal to 1 by f of d into e to the power 2x. So as we know that if e to the power ax will be there, then the answer will be 1 by fa into e to the power 2x. So here a is nothing but 2. Okay, here a is nothing but 2. So 1 by d square minus 1 e to the power 2x. So here a is nothing but 2, right? So here you can just write like this. Here you write a equal to 2. We have to put a equal to 2. A equal to 2 in bracket. Because e to the power 2x. So coefficient of x is nothing but a. Coefficient of x. Coefficient of whatever may be we have, that will be considered as your a. So here a is 2. So here f of d is nothing but d square minus 1 e to the 2x. As a is your 2, then we have to put a value here. So a value here means 2 square. 2 square is 4. 4 minus 1 e to the 2x. So 4 minus 1 is your 3. So 1 by 3 e to the 2x, that is your yp. So general solution y equal to yc plus yp. Yc already found. We found that this one plus yp equal to this one. So this is your general solution of the differential equation, non-homogeneous linear differential equation, this one, right? Now we are going to go for another question. Here it is given that just I have been modified. Instead of y, we have 4y. So d square y by dx square minus 4y equal to e to the power 2x. Then here d square minus 4 equal to y equal to e to the power 2x. Here I am considering only yp. Okay, only yp for your confirmation, that here we are going to get f of d will be equal to 0. Okay, see here yp equal to 1 by d square minus 4 e to the power 2x. Okay, so for this case we have to put, instead of d equal to a, here a equal to 2. So if I put here 2 square equal to 4, 4 minus 4 equal to 0. So 1 by 0. So here we found that the so-called f of d equal to 0. For this case, what to do? That means the formula is valid. This rule is valid, that f of a not to be 0. So here f of a, f of a we found 0. Then what we have to do? For this case, that is for f of a equal to 0, what we have to do? 1 by f of d e to the power x will be x into 1 by f dash a into e to the power x, where f dash a not to be 0, right? If we found f a equal to 0, then the yp will be, that is your 1 by f of d e to the power x will be x into 1 by f dash, whatever f d we have. First we have to take the first derivative, then we have to put a value at a at d, okay, into e to the power ax will be the yp. Okay, so now first of all we have to prove this one, that if f of a equal to 0, then this value will be this much. First we have to prove, then we are going to solve this problem by using this method. Okay, so first we have to prove that this equal to this one when f of a equal to 0, right? We know that f of d, this is a proof. Okay, this is proof, this is nothing. We know that f of d equal to a1 d to the power n, a2 d to the power n minus 1, and so on up to an, right, plus an. If f of a equal to 0, that means d minus a is a factor of fd. Here you have to concentrate and try to understand. ध्यान से देखो कि अगर a पूरा का पूरा, अगर मैं यहाँ पे a डालता हूँ और ये 0 हो जा रहा है, इसका मतलब ये है कि d minus a will be a factor of this one. Okay, if f of a, if I am going to put a at each point of d and I am getting 0, that means f of d have one factor d minus a. So if d minus a one factor will be there, that means a minus a will be 0. So hence total fd will be 0. So f of a, if f of a equal to 0, that means d minus a has to be a factor of f of d. Got it? So therefore f of d, this one, can be written as d minus a into f of d. So f of d is the function contains all the terms except d minus a. As I told, if f of a equal to 0, that means d minus a will be a factor of f of d. So f of d, I can write d minus a, that factor I taken outside, into all other d factors, that is represented as f of d, capital F d. Okay, now 1 by f of d e to the power x will be equal to, this is fd, we have been considered this one, so 1 by d minus a into fd into e to the power x is equal to 1 by d into, first we have to operate 1 by f of d into e to the power x, 1 by f of d into e to the power x. So here, as I told, d minus a is one factor has been taken outside, and this factor not contains d minus a factor. See, f of d, this f of d not contains d minus a. So if I am going to put instead of d a, then I am not going to get the 0. So e to the power x easily operate for the f of d, right? So 1 by f of d e to the x can be written as 1 by f of a. This a can be substituted for all the d's. D, wherever we have the d, that a can be substituted. So 1 by f of a e to the x. Simple. That means we are applying this rule, that 1 by f of a e to the x. Yp, if 1 by f d e to the x, then 1 by f a into e to the x. This rule I have been applied for this one, because this fd not contains d minus a. So if I am going to put a for each d, then I am not going to get 0 for this f of d. Okay, so 1 by f of a e to the power x and 1 by d minus a, uh, as such I have been written over here. So 1 by fa will be a constant taken outside, 1 by d minus a into e to the power a x. Then what we are going to do? Here you can see that 1 by d minus a e to the power x equal to, if we have like this, then this value is nothing but e to the power x integration of e to the power x into e to the power minus ax into dx, right? See, here one thing you have to remember, this one remember, but later I will prove this one. Okay, that means if we have 1 by d minus a into x, then this can be written as this can be written as e to the power ax integration of this x value or x function into e to the power minus ax dx. Okay, so here in this case the x is nothing but e to the power ax, right? Here in this case x is what? E to the power x. So 1 by dA e to the power x will be how much? E to the power x. Here I written e to the power x. Integration of x, capital X, is what? E to the power x. Here I written e to the power x into e to the power minus x dx. Okay. Suppose I am going to say that uh, I have another function. Suppose like this. Suppose we have d minus a into, suppose, into x square is there. Into x square is there. Okay. So this value will be nothing but, here you can see that in general e to the power ax that is your here a, suppose I am going to take that this a value is 2, then as per this rule e to the power ax, that means e to the power 2x integration of, instead of x what we have to write? X square is the function, x square into e to the power minus 2x dx. Okay, like this you have to uh, we have to write, and this expression you have to remember. That means this expression you have to remember, and later on I will prove this one, how this 1 by d minus a into x e to the power will be equal to e to the power x integration of x e to the power minus ax dx, that I am going to be prove. Okay, so here as x equal to e to the power x for this case, so 1 by d minus a e to the power x can be written as e to the power x integration of e to the power x into e to the power minus ax into dx, right? So that implies here 1 by f of d e to the power x, 1 by f of d e to the power x will be equal to 1 by f of a, capital F of a is here I written as such, into this much is nothing but this one. Okay, e to the power x integration of e to the power x into e to the power minus x dx, right? Now here 1 by f of a e to the power x, here e to the power x e to the power minus x, so e to the power 0 will be 1 only dx, and dx integration is nothing but x. So we got that x, here x by f of a, x by f of a, capital F of a into e to the power x into e to the power x, right? So we found 1 by f of d, small f of d into e to the power x is equal to ax into 1 by f dash a into e to the power x. Here I written f dash a because f dash a is nothing but capital F a. How it is? Here I written also f of a is nothing but small f dash a. How it is? Because here we defined that f of d equal to d minus a into capital F of d. Okay. Now differentiate this side and this side. So this is f dash d equal to, here you can see we have to use the product rule. So d minus a, this one f dash d plus f d, if differentiation with respect to d. See, f dash d means this is the differentiation with respect to d. With respect to d, if I am going to differentiate d minus a, that means d by d of d minus a is nothing but 1, right? Because d by d of d equal 1, d by d of a is the constant equal to 0. So this value 0, so it will be 1, this value will be 1. So d by d of d minus a is 1, right? Now we have to put instead of d equal to a. So here a minus a will be 0, this term is going to be cancelled. So f dash a equal to capital F A. So only for that, instead of f a, I have been substituted f dash a. But here we have to remember, this will be valid for f dash a, this denominator not to be 0. Again, if f dash a will be equal to 0, अगर ये 0 हो गया, then what we have to do? Then 1 by f of d e to the power ax, the same method we are going to be used, and we are going to get another x is going to be multiplied. Here you can see what is the difference between what is the difference between this and this. You just see difference between this and this. Here e to the power ax is there, e to the power ax is there, only one x is multiplied extra divided by differentiation of denominator, this one, right? So if again f dash a equal to 0, then same procedure we have to follow, and we are going to get again another x is going to be multiplied, so it will be x square and its derivative, that means f double dash a into e to the power ax. So here we have to remember one thing, that f double dash a not to be 0. If double dash a, if f double dash a equal to 0, then answer will be how much? Then answer will be x cube 1 by f triple dash a into e to the power ax. Okay, that means 3 times derivative, and we have to substitute a. Like this we have to do the or solve the problems, numericals. So now using this rule, we are going to be solve this one, this question. Okay, this question. So let's see. Here d square y by dx square minus 4y equal to e to the power x. So here auxiliary equation is your what? M square minus 4 equal to 0, m equal to plus or minus 2. So complementary function will be this one. C into these two distinct solutions. So c e to the 2x plus d e to the power minus 2x, and corresponding yp, now we are going to find out, that is your d square minus 4y equal to e to the 2x. So yp is nothing but 1 by d square minus 4 into e to the 2x. But here f of a equal to 0. See here, if I am going to put 2 over here, this will be 2 square minus 2 square, that means 4 minus 4 equal to 0. So here f of a, that means 2 square minus 4. Okay, that means 2 square minus 4. Clearly you have to write. That means 2 square minus 4 equal to 0. So for that, what we have to do? Yp will be x into derivative of this one first. Derivative of this one, and we have to substitute a in d. So derivative of this one is nothing but 2d into e to the x, but we have to consider f dash a. F dash a means first we have to consider derivative, then we have to substitute a value instead of d. So wherever we have d, there we have to substitute a value. So derivative of this one is how much? 2d. Now we have to substitute a value at each point of d. So here I have to put a value is your 2. 2 into 2 equal to 4. So x 1 by 4 into e to the 2x. So x e to the 2x by 4. So y will be equal to, the general solution is your complementary function, this one, added with particular integral, this one. Okay. Now second rule we are going to be follow. If the source function or right hand side x function of a non-homogeneous differential equation if it is in the form of x to the power n. Suppose we have only x to the power n, then what we are going to be found about yp. So for this case, yp or particular integral will be 1 by this c 1 by f of d, which is operate on x. This is the fundamental one, this is the primary one, that yp is nothing but always, as I told, yp is nothing but always this 1 by f of d will be operate this function. Okay, but in our rule 1 we have been discussed in detail about when this will be exponential function, what are the procedure we have to follow. Okay, now we are considering the if x equal to x to the power n, then what will be the procedure. So in general, yp equal to 1 by f of d into x to the power n, this one we know, or f of d inverse x to the power n. So here 1 by f of d, the operator on the x to the power n. So only if x will be is the a polynomial, this x to the power n is nothing but polynomial. Okay, polynomial. So that means if we have a polynomial in our RHS of non-homogeneous linear differential equation, then we have to follow this rule, that is your 1 by f of d will be considered as f of d inverse into x to the power n. And here two important series you have to remember, that 1 by 1 plus x is nothing but 1 minus x plus x square minus x cube plus x to the power 4 minus x to the power 4 5 and so on. That means plus or plus minus alternate sign will be come up for 1 by 1 plus x. Remember, 1 by 1 minus x all are plus, 1 plus x square plus x cube plus x to the power 4 x to the power 5 and so on. This is nothing but so-called Taylor series about x equal to 0. That means if we are going to consider this is the function, that is your f of x equal to 1 by x, then the Taylor series of this one about x equal to 0 is nothing but this one. Taylor series of this one about x equal to 0 is nothing this one. You can check by rough in your rough. Okay, or you can say that is the binomial expansion of 1 plus x to the power minus 1 is nothing but this one. Binomial expansion of 1 minus x to the power minus 1 is nothing but this one. So in any name you can remember, but I suggest that you have to remember that if 1 by 1 plus x, then the Taylor series of this one is this one. 1 by 1 minus x is this one, the expansion. And here always you have to remember that this x here always you have to remember, always x is less than 1. Okay, this x is always less than 1. Then the series will be this one. Why it is, how it is, you are going to be study in detail about your in your fourth semester. But in little bit maybe you have studied in your first semester unit 1. So with the help of that you can evaluate the Taylor series of 1 by 1 plus x, 1 by 1 minus x about x equal to 0 for this one and this one. Okay. So here x is always less than 1. How it has to be less than 1? Why it has to be less than 1? For these things you are going to be studying in your fourth semester. So no need to worry about that. You just remember these two series. It is required to solve this type of problems. Right? Now we have to go for a numerical, that is your d square y by dx square minus y, x to the power 4 is there. So here is the polynomial, only polynomial. There is no sin x, no cos x, no trigonometric, no exponential, so only polynomial. So here auxiliary equation is nothing but m square minus 1 equal to 0, m equal to plus or minus 1. So hence complementary function equal to c e to the power x plus d into e to the minus x, right? So now yp particular integral will be d square minus 1 y equal to x to the power 4. So yp will be equal to 1 by d square minus 1 x to the power 4. Okay, so here if I'll take minus 1 common from these two, then it will be minus 1 minus d square into x to the power 4. Remember, we have to use this expansion series whenever it is in the form of 1 by 1 plus x, 1 by 1 minus x. 1 by 1 minus x series is this one. Okay, you could not say that 1 by x minus 1 series is this one. No. So here you can see we have d square minus 1. To apply this expansion, I have to convert this d square minus 1 to 1 minus d square. So if I will take minus common from these two, then it will be minus whole into 1 minus d square x to the power 4. You got my point? Now I am going to be use this one, the expansion of 1 by 1 minus x. Okay, so here minus is there, minus is there, 1 by, see, 1 by 1 minus x is your 1 plus x square, and so on. Here 1 by 1 minus d square, then what will the expansion? Expansion will be here 1 plus x. So here 1 plus d square, because instead of x here it is d square. So it will be 1 plus d square, d to the power 4, d to the power 6, and so on. See, if 1 by 1 minus x is equal to 1 plus x square plus x cube, and so on. So instead of x, d square is there, no? So instead of x, d square is there, means here we have to put d square. Here we have to put d square, again square is there, d to the power 4, d square to the power 3, so d to the power 6, and so on up to x into x to the power 4, the given function, right? So now yp will be equal to minus, here I am going to multiply x to the power 4 with each term, x to the power 4 into d square x to the power 4, d to the power 4 x to the power 4, d to the power 6 x to the power 4, and so on. But here we have to stop our terms, because why you can now you can understand well. See, x to the power 4 is there. See, d is nothing but d by dx, first derivative. D by dx is nothing but d by d. So 1 by d is nothing but integration of dx, first integration, right? So here d square means double derivative of x to the power 4. So single derivative is your x to the power 4, single derivative is your 4x cube, double derivative is your 12x square. So double derivative of x to the power 4 is nothing but 12x square. Then this is nothing but fourth derivative of x to the power 4. So third derivative is your 12 into 4, 24x, fourth derivative is your 24 only. So fourth derivative of x to the power 4 is your 24, right? Then sixth derivative of x to the power 4. See, here fourth derivative is 24, fifth derivative is 0, sixth derivative is obviously 0. So sixth derivative of x to the power 4 is 0, no need to write. So again, likewise, only for that, here we have to stop to take the terms, because d6 x to the power 4 we can get 0. Again d8 x to the power 4 will be 0, so no need to take those terms, higher order terms. Okay, so our answer, we found that yp equal to minus x to the power 4 plus 12x square plus 24. So in general, the solution is complementary function and particular integral. Complementary function we found this one, okay, and this is the particular integral. So this is the answer of this question. Okay, so next we are going to discuss rule 3, that is your if x is a trigonometry function, that is your sine x or cos x, then what will be the yp, that we are going to discuss in our next class. Also we are going to discuss another rule, that if x equal to, this is your rule third, rule fourth, if x equal to e to the power ax into fx, that means exponential function multiplied with another function. That means I can give you an example, that if x equal to in this format, e to the power 2x into x to the power n, or e to the power 2x into sine 2x, like this, then what will be the answer, or how we are going to be find out. That detailed rule theoretically we are going to discuss, and we are going to do the corresponding problem itself. And another rule, rule 5 also we are going to discuss, that is your if x will be any function except e to the power x, exponential and trigonometric and polynomial, any other function, if x, then what will be the rule, that we are going to discuss, and corresponding numericals also we are going to discuss. So here we are going to stop our discussion today, and we are going to meet in our next class. So thank you so much for watching this video. Thank you.